Hello, my friend. Welcome to my channel. So today I'm going to discuss discrete probability distributions. As you know, to be a valid discrete probability distribution, these two conditions should be satisfied. The first one is the sum of the probabilities of all the events in the sample space must be equals to 1. And the second condition is the probability of each event in the sample must be between or equal to 0 and 1. So let's determine whether each distribution is a probability distribution. So that means we are going to check these two conditions for all these examples. So let's look at the first distribution. So x is the random variable and 0, 5, 10, 15, 20 are the values that can assume this x variable. And this p of x, which is probability of x, is the probability of each of these x values. Probability of x equals 0, 1 over 5. Probability of x equals 5, 1 over 5. So likewise, we have this distribution. Now we are going to check the above two conditions. So let's check the first one, which is the summation of pi should be equals to 1. Let's check the summation of all the probabilities. 1 over 5, so it's 5 times, right? So this equals 5 over 5, which is equals 1. That condition is satisfied. The second one, so it is all probabilities 1 over 5, right? 1 over 5 is, as a decimal number, it is 0.2. So 0.2 is in between 0 and 1. So this condition also satisfies. So therefore, this is a probability distribution. So let's look at part B. Look at the distribution. So random variable x can assume 0, 2, 4, and 6. The corresponding probabilities are negative 1.0, 1.5, 0.3, 0.2. So before we check the first condition, by looking at this distribution, you can directly identify this value. So this is a negative number, right? So we cannot have negative numbers because all the probabilities should be between 0 and 1, right? Inclusive. So here negative 1 is outside of this range. Therefore, because of this one, this distribution is not a probability distribution. Okay? And as you can see, if you look at this value, it is greater than 1, right? It's 1.5, which is greater than 1. So, because of that, not a probability distribution, right? You don't need to check the other condition in this case. Look at part C. Random variable x can assume values 1, 2, 3, and 4. The corresponding probabilities are 1 over 4, 1 over 8, 1 over 16, and 9 over 16. So let's, as you can see, the probabilities 1 over 4, 1 over 8, 1 over 16, 9 over 16. All these probabilities between 0 and 1. So this condition is okay. Now we have to check the other condition, which is summation of pi. 1 over 4 plus 1 over 8, 1 over 16 plus 9 over 16. So let's look at the summation of these. So my common denominator is 16. So 1 over 4, I multiply by 4 to get the 16, numerator and the denominator, and plus 1 over 8. So I multiply numerator and denominator by 2. Then that is 2 plus 1 plus 9. So this is 9 plus 1, 10. 10 plus 2 is 12 plus 14 is 16 over 16, which is 1. Okay. So both conditions are satisfied. Therefore, this is a probability distribution. And let's look at the last one. The random variable x can assume values 2, 3, and 7. Corresponding probabilities are 0.5, 0.3, 0.4. As you can see, all these probabilities between 0 and 1. So this condition is satisfied. Let's check the other condition, summation of all the probabilities. 0.5 plus 0.3 plus 0.4. So what is this? The summation equals 1.2. So this is not equals 1. So in this case, not a probability distribution. Okay? Both conditions should be satisfied to be a valid probability distribution. So this is how you determine the given distribution is a probability distribution or not, right? This is how you check it. So I hope you understand this one. If you have any doubts, you can comment. If you want to see more videos like this, please subscribe to my channel. Thank you so much for watching this video. Bye.